All right, here we go. Pre-Cal students, we are here live. We're going to part 3, unit 4 and 5. Again, you should see the other ones above me on the other 2 units. Let's get underway and we'll go from there, all right? We just left off with the top of unit 3, and you'll notice that as we continue, we're going to do the unit 4 and 5 of the 2 units we have not quite done yet, all right? So we'll start with unit 4. We'll go to number 1. Then after that, hopefully that will help you in studying and reviewing for the exam. All right, let's do it. Now in unit 4, what we have in unit 4, it says this on number 1, find the sum of the infinite geometric sequence. Well, anytime we have something that's infinite, we got to try to find what that sum would be. What would be the equation for that infinite geometric sequence? Does anyone know? With unit 4, we'll go to number 1. Then after that, hopefully that will help you in studying and reviewing for the exam. All right, let's do it.
Like literally, what's happening?
Now in unit 4, what we have in unit 4.
5. What's that?
Am I good?
Apparently screenshotted. It says it's live though.
I'm still live. Oh my goodness, that scared me to death. I just heard myself in a podcast.
That was so weird.
That was awesome. Good. Well, at least I don't have to stop it.
Good.
Yeah, my word. That was weird. I'm scared. I'm scared right now. I have no idea what just happened. All right, so infinite geometric sequence formula. And again, I'm going to look that up because I forgot. And that's something, again, you'll have on the test, be able to determine that on there. So again, when you look at the infinite geometric sequence, the important thing to look at is S of n equals a sub 1 over 1 minus r, okay? Where r is the common ratio and a sub 1 is the first term, okay? Now, when we look at the where it's not infinite, the difference is the sum will be a sub 1 times 1 minus r to the n all over 1 minus r. And again, these will be given to you, so no stress on how to come up with those. So now the first one says find the sum of the infinite geometric sequence. So since we know we're going to use this equation, we're going to plug in the first term, -7. We're going to plug in for a sub 1. And then we know that r will be our common ratio. What's our common ratio?
1/3.
Yeah, so it'd be 1 minus 1/3. Very good. So now since I have the bottom, 1 minus 1/3 would be 2/3. So I have 2/3 on the bottom over -7. We're going to divide these out, so we're going to flip the top to multiply by the reciprocal of the top. So -7 times 3 over 2 equals -21 over 2 as my answer for the infinite geometric sequence in that way. All right? Now someone's calling me. This is really, really strange. This is like, it's my wife.
Enter.
You answer it? On my podcast, answer it?
Yeah.
Oh, this is going to be awkward. My YouTube followers, I apologize. She didn't answer. She must have butt dialed me or something. All right. So she was just thinking about me. It's easy. It's easy to do. All right. So when we find number 2, when we find what the I'm joking. I'm not that conceited. Just a little bit. No. But when we find with this next equation, we're trying to find the sum of a specific number of terms in that way. Oh, this is really creepy. Hello. Hey. Okay, good. Well, that's awesome, baby. Awesome. Sounds good. it's been a weird class the last 15 minutes. You're in class right now. You can say hi. And she says hi.
Hi.
All right, sounds good. Well, love you. All right, bye.
Relationship goal. So cute.
All right. So sorry about that, y'all. So when I solve for this is gonna be the weirdest podcast to watch. I apologize. Please skip all that. All right. So when I look at what the A1 is, A1 sauce would be 12 because that's our first term. Okay. Remember that within any term we have A1 sauce. That, by the way, it's my favorite sauce. And then R to the N minus 1 power. I don't know why I'm saying this stuff.
Why do you like it?
I don't know. It's really good. Say that again, Laura.
Wait, are you still doing the one?
Still doing
Where'd you get 12?
still doing 2. We're doing 2 now.
Oh, okay.
This right here was number 2. I know I've been all scattered. Lord, I don't know how you can't pay attention, for that. I'm trying to mess it up. Literally right now I'm all over the place. I was focused all throughout today, and then now today hit. So now I have 1 minus R to the N. Okay, so we know, what is R? What's our common ratio? What's our common ratio? If we look at 2, and this is our formula, right? Yeah, there you go. Good. So we'll do this. We'll take that out. We'll just put negative 1/2 to the nth power. What's the nth power? N is the amount of terms, right? So what would the amount of terms be?
12.
I think is it 10? It says find the sum of the first 10 terms. So 10 would end up being what my N would become there. Now on the bottom, we'll have 1 minus R, or we'd have 1 minus negative 1/2. Okay? So what I would do is this on the bottom, let's simplify that to where we would now have 12 times 1 minus negative 1/2 to the 10th, all over 1 plus 1/2 would be 3/2. So we'll just put it on the bottom there. Now what I would do is in my calculator, we're going to plug this in. So we want to do it like one at a time. So where we do 1 minus negative 1/2 to the 10th, put that in, 1 minus negative 0.5, we could say, to the 10th power. Kind of put that in. Right on. Make sure you include parentheses in there. I know it's easy to miss. You want to put that in. Once I get that, I'll divide by 3/2 or 1.5. No, it's okay. No, I mean, we just need more. It'd be good. I mean, not like we've had enough distractions on my part. So you're good to go. Y'all can have as many as you want. So now we'd have 7.99 is what I got for the sum there. I could be maybe off by maybe a 0.01 or something like that, but that's what I got when I plugged it in my calculator. All right, make sure that in here, the big thing is make sure you put that in parentheses, and do not change the 2 negatives to a positive, because that may not be the case. Make sure you use order of operations, PEMDAS, and you'll be good to go. All right? All right, questions? Questions? All right, sweet. Do we need to go number 3? Everyone's like, yes, please do that. All right, perfect. Remember with this equation, and I might have to change it around a little bit, but you'll get the idea. It's NCR, right? And remember, it's like x to some power, y to some power. Do y'all remember that?
Mm-hmm.
All right. Remember that with the n is the total amount of what?
The total amount of
Terms, right? How many terms are there? In the case where it's 3x plus 2y.
8 terms.
To the 8th, we know that the 8 would go where? The n. Yeah, exactly. So we'll have 8, choose, and since we're looking at r here, we know that x is going to end up being to the, what do we say, x to the 3rd?
Mm-hmm.
Y would be to the 5th power, okay? Remember that the 5th is always the value that will be included in my r. Very good. Very good.
Is it the higher value?
Say that again.
The higher value or just the y?
It's always whatever's with the y, right? Because if you think about it, it will be x to the 8th x to the 7th, x to the 6th, x to the 5th, right? X to the 4th, x to the 3rd, so on and so forth. When x is decreasing, what's y doing? Y is increased, so it'll be y squared, y to the 3rd, all so on and so forth. And so because of that, that 5 will always go with that c there. So if it's 8 choose 5, what we can do is in our calculator, we could do 8c5. So if we go to catalog, okay. By the way, you know what my favorite catalog is on an airplane? You ever go on those?
Yeah.
Yeah, Sky Mall. Is it Sky Mall, Jess? Yes, Sky Mall. So today's podcast brought to you by Sky Mall. Come and get the biggest bone you can for your pet at home. They have the weirdest things on there, you know? These two have the weirdest things. All right, let's go 8 choose 5. 8 choose 5. Yes, sir. Yes, you may. Go ahead. All right. Did y'all get that there? What'd you get?
56.
56. Very good. All right. So we'll go up yonder. We'll go 56, x to the 3rd, y to the 5th. But here's the problem. What is x and what's y? What's x? Look at the problem. What is represented as x? Not just x.
3.
There's a 3, right? So not only is the x cubed, we also have to have a 3 cubed, right? And not only do we have to have a 3 cubed, we also have to have 2 to the 5th power. So 3 to the 3rd should be 27. 2 to the 5th should be 32, I believe. So what's 32 times 27 times 56? That should get us where we're at. Does that make sense or no? Oh, I'm sorry. Let's go over here. 56 times x to the 3rd, y to the 5th, right? Since x is to the 3rd, 3 will be to the 3rd, right? And so 2 will be to the 5th. So this will be 27 times 32 times 56 gets us, what do we get?
That's a big old number.
That's a big old number. That's right. $864. I think it's a little more than that. Did you do 27 times 56? That's okay. 1,512. Very good. That's my paycheck yesterday. 1,500. I'm joking. 1,512 x to the 3rd, y to the 5th would be my answer. Okay.
Wait, don't you do 56 times 27 times 32?
That's what I thought. Yeah.
I got 48,380.
That's
48,300 what?
84.
384. Jess, do you see what you did there?
Multiply all 3.
Yeah, you got to multiply by all 3 because they're all 3 different values. Does that make sense?
Yeah.
So, yep, you're exactly right. You got to multiply by all 3 of those there. All right. What about number 4? I think we're good on number 4, don't you think?
Don't you just plug it into your calculator?
Well, yeah, you could do that, or you could just put in first 5 terms would be plug in 1, plug in 0, or plug in 2, plug in 3, plug in 4, and after that you should be good to go. The next one, number 5, do we need help on that? Number 5 we do? Okay. And I'm going to put Pascal's triangle on the note card that I will give to you. Make sure I've got all that too. All right, so in Pascal's triangle, Pascal came to me yesterday and told me, gave me a little help here. Gave me this triangle, all right, that slowly digresses downward. And I'll just put it just like this. What do we start? What power do we start at the top?
0.
0, then 1, 2, 3, and 4. And I think we went to 3, right? So it should use this one right here, 1, 3, 3, and 1. So it should be 1 with a 3, with a 3, and with 1. So this will be x to the third, x squared, x, and nothing, right? So this will be y to the third, y squared, and y. Okay? Now, what about in this case? What do we do now? Once I get to this point, I'll just put a plus between each. What do we plug in for x and y? Kind of what we did.
2.
Yeah, so let's put 2 in for x. So 2x will plug in for x, and then negative 1 will plug in for y. Be squared, so be to the third. All right, so let's do this. 2x to the third will be what? Good, yeah, good, Jess. 8x to the third. What about this next one? 2x squared would be what? 4x squared times 3 would be? So 12x squared times negative 1 would be? Yeah, negative 12x squared. Do y'all follow me on that? That I know it's kind of hard to see there.
What about the y?
Yeah, the y was just negative 1, right? So the negative 1 only attributed to the change in sign in the front.
So you don't put the y's anywhere?
Well, what was y? Oh, yeah, no, it's negative 1y. Okay, I got you. Yeah, so it should be 12x squared y. I put negative 1 because I thought when we said it, I heard 2x minus 1. It's really 2x minus y. So again, just so those of you at home, my YouTube followers can follow me, 2x minus y to the third, all 5 of you, and then we're good to go. So now what about this next one? 2x would just be there. 2x times 3 would be 6x. And then we'd have negative y squared would be just y squared. So it should be, I believe, 12x y squared. Is that right? Oh, no. It should be 6x. I'm sorry. 6x y squared. All right. Is that correct? Paul, am I wrong on that?
No, that's right. Not wrong on that. No, not wrong.
Okay. Where am I wrong on? Am I wrong on one?
I think I overthought it.
Go ahead. No, please, because, again, you're good.
No, I don't think.
Okay.
I don't.
Right. If you catch me on one, let me know.
I thought.
The bottom one, the 1y cubed, would be negative y to the third power, which would just be what? Negative y cubed. So my answer should be 8x cubed minus 12x squared y plus 6x y squared minus y cubed. Sweet. Right on. All right, so that was number 5. Does that help? Number 5? All right, let's go to next one, number 6. Now this one's a tougher one. It's negative 3, 3 halves, negative 3 fourths, 3 eighths, and so on and so forth. And it tells us to write a rule. Now, does anyone have any idea of what we could do in order to help us with this? We know we're going to plug in for n. We'll plug in 1, 2, 3, 4, so on and so forth. So what could we do with this to be able to write some sort of rule? There's maybe a couple ways we could do this. Let's start with the top. What could we do with the top? Does anything change on the top?
No, it stays constant.
Stays constant, right? So what could we do with that top?
Oh,
So because it's who's here, but you can kind of hear me here. That was Aaron. There we go, Aaron.
that was my bad.
You're good to go. You're good to go, man. So what can we put on the top there? What is on the top? What's consistent?
3.
3. Yeah. So
The
let's.
signs change.
The only thing that changes is the sign. So here's a good way. Here's a good way to do it. And again, anytime there's a sign change, think about it with this: negative 1 to the n power. Plug in 1. What do I get out? Plug in 2. What do I get out? Plug in 3. Negative. Does that make sense? So what you could do is just put in negative 1 to the n power. We could check it afterwards. So that will change the sign. Okay, so that right there, that -1 to the n power is a tool that we use to change the sign when we plug it in. Now, what about the bottom? What is it doing each time? It's multiplying by 2, right? So what can we put on the bottom in order to do that? 2x, and in this case, we'll just use n because that's what they've been using consistently. So we'll just do 2n. And it'll be 3 times 1 or -1 to the n power all over 2n. And on your answer sheet, you might get something that looks a little different. That -1 to the n might be on the bottom, but either way, to get you the right answer on that. And you could, again, check it by plugging in specific values. All right? And actually, as I noticed that, I think that might be a kind of wrong. Look right here. Plug in 1 for me. All right? On the top, we'll get -3. But what do we get on the bottom if we plug in 1? 2, right? What do we need to do? It's not just n, it's what? It's not n squared. Because if I squared it, it would still would be 2, right? Is it 1 squared? Good. We want to do 2 times n minus 1, right? Try this. All right, plug in 1 now. 1 minus 1 is 0 times. Well, does that get us there? It doesn't. So what can we do? We got to plug in 1, right? And get 1 on the bottom. But we got to keep multiplying by 2. So what could we do there?
Start with 2.
Start with 2? Okay, so how so? How so, Aaron? So keep the top the same. Top is good, right? So just start with 2 on the bottom? Because this right here is like a 1, right? So we're multiplying by 2 each time. We know that, right? So we know it's being multiplied by 2n. But when I plug in 1, it's not quite getting me there.
If you plug in 2 for n, it would be 1 times 2.
So what can we do on the bottom to get to where there's a 1 there?
Divide by what's. Or you could.
1/2. If we put a 1/2 there, I don't know if that'll work. Like just put a 1/2 there on the bottom.
It would be 2 to the n.
I think you got it. Yeah. Well, it would be 2 to the n minus 1, right?
Okay, we start with 1.
Correct. Why? Why is it that case? Because if it's a multiple of 2, right? So 2, 4, 6, 8, 10, or 2, 4, 8, 16, 32. If it keeps going that way, what we want now is that first one, if we plug in 1, it'd be 2 to the 0 power instead of 2 times 0. So 2 to the 0 power is now 1, right? And if we keep going, we could continue and kind of go from there. And that's a challenge, right? That's probably one I won't have as multiple choice if I had it. To try to see how far you could go to where maybe if you got to this point, maybe you get part of it back. This right here, again, was a little bit of a challenge, but we got to it. That's pretty good. Nice job, Aaron. All right. Let's go to the next one. Next one says write a rule for the following sequence. Now, I think this one maybe gets a little bit better because what changes on the top? And again, we'll put those out here, 3 over 1, 3 over 4.
Nothing.
Say it again, Paul.
Nothing. There's no sign change. It's all constant.
So on the top, we just keep it as 3, right?
3 over n squared.
Bingo. Yeah, Lauren had it, and I heard of Lauren, and that's why I was going to Paul too, just to see. Paul had it there. Lauren had said it perfectly. So if we put it n squared there, 3 over n squared would actually be what our equation would be. Lauren, great job. Very good. I'd already heard you, so I wanted to make sure we were good on that. Excellent. All right. Next one says find the sum of the infinite geometric series, if possible. Do we need any help on that one? I think we just did that one, didn't we? We had done one like that, very similar. So I think we are good on that. Number 9 is 1, 2. We want to make sure we go over. This one's one where we talk about the sequence defined recursively, meaning once we plug in a value, if 15 is the first one and we plug it in, what do we get out if we plug 15 in for number 9? We'll put this in here. We plug 15 in for ace of K, and we add 2.5 or 5 halves. 15 plus 2.5 gets me what?
17.
Good, Lauren. So if 17.5 is my next one, what do I do with that if it's defined recursively? We just keep adding it, right? So then we put 17.5 back in. So 17.5 now plus 2.5 would be 20, right? Then add 2.5 again, 22.5. So defined recursively means what you get as your answer is what you plug in, right? And we just keep going and going and going and going. So that's what we're talking about in terms of defined recursively, okay? Now, are there any questions on Unit 4 that y'all see there that maybe you have questions on? We finished that Unit 4 there. Paul, you got one?
Trying to think of one, but you covered everything.
We at least hit on it a little bit. All right. Let's do this. Look at Unit 5.
I go to the restroom.
Yeah, go ahead. Go ahead, Paul. Unit 5, if you look at numbers 1 through 9, I know that we had just taken a test on that. Is that stuff that we need to go over again? If you could throw off number 6, by the way. Throw off number 6 on that Unit 5. All right, talk to me now. What do you think on numbers on Unit 5? You think we got that down? I know some of you aren't even concerned with the exam because you're not taking it, but just checking to make sure. Are we good on that one? Yeah? Okay. Sounds good. Well, Unit 5 we can kind of put off until in class tomorrow. We'll look at that a little bit. This is Coach Jay signing out with Unit 4. We'll look at Unit 5 a little bit tomorrow. Hope you have a great day, and bye.